Hello, in this video I'm going to be going over how to write an expression for the equilibrium constant K. For these type of problems we always start with a chemical reaction, and it's an equilibrium equation, meaning the arrow is a double arrow. It can go to the products or it can reform back into the reactants. And a good rule of thumb for writing an expression is always the concentration of the products divided by the concentration of the reactants. So we're going to write this. Equilibrium constant Kc equals the concentration of the products over the concentration of the reactants. And we need to write the orders, or also known as the coefficients, as the exponents. So our product, we have two NH3s. So we're going to write that as our exponent. And our hydrogen, we have 3 H2s, so that's going to be our exponent of the H2. And N2, there's just 1, so it's an exponent of 1, basically. Alright, and that is my equilibrium constant K expression. Products over reactants. This only works if you have a gaseous product or reactant or an aqueous, meaning dissolved in a solvent. If you have a solid or you have a liquid, those guys would be omitted. So trying number 2 out. Here we got a solid, and gas. So our Kc expression is going to still be products, the concentration of our products, O2, and there's 3 of them, so it's to the power of 3, divided by our reactants. And I left out KCl because it's solid, it's omitted. And then my reactant's solid, it's omitted, so it's just over 1. Or you could just say Kc equals O2 to the power of 3. Alright, now what happens if we're actually given the concentrations? Then what we have to do is plug in our numbers in their proper spot. And going back, we had NH3 to the power of 2, NH3 to the power of 2, we had N2 to the power of 1, and H2 to the power of 3, just double checking. Yes. Alright, that was from the previous side, the equilibrium expression. Now we're going to plug in the numbers. So for NH3, it's 0.0100 molar squared, divided by 0.0200 molar to the power of 1, times 0.0200 molar to the power of 3. This is the trickiest spot, plugging this in your calculator. If you have a graphing calculator, the best way to do it is to put in parentheses your entire numerator. So in parentheses, 0.01 squared, end parentheses, divided by parentheses, 0.02 times 0.02 cubed parentheses. Otherwise, you're going to get the wrong answer. Alright, so when I plug this in, I get 0.01 squared divided by 0.02 divided by 0.02. 625. And that is my equilibrium constant, my Kc. So what does that number mean? Basically, important to know, right here we've got Keq. When it's greater than 1, products are favored. So what's happening is, well, going back, I have 625, so my products right here are being favored, meaning I have more products being formed than the reactants being reformed from the product. So I'm going to be producing way more NH3 than I am N2 or H2. If my Keq is less than 1, or my Kc, the reactants are favored at equilibrium. In that case, my N2 or H2 would be favored if my Kc was less than 1. But it's not, it's greater than 1, therefore NH3 is favored. And that's how you write an equilibrium constant expression, and that's how you solve it when given the concentrations.